When you think about high-impact AI projects that directly influence finance, hiring, and the future of digital lending, loan default prediction stands out as one of the most powerful options for students preparing for placements. This slide introduces the project by showing how machine learning evaluates a borrower's ability to repay loans using signals like credit history, income, employment stability, and past repayment behavior. It matters because digital lending is exploding across banks and fintechs, and billions in loans now depend on automated risk models. Accurate prediction protects lenders from heavy losses while helping deserving customers access credit safely. You will see how this applies to personal loans, home loans, credit cards, and even business loans, which makes the project feel real and industry-ready. This gives you exposure to the same logic used by credit bureaus and large lending platforms. Recruiters value this project because it shows you understand financial risk and can turn complex applicant data into meaningful decisions. It builds confidence in your analytical mindset and proves you can design systems that improve profitability and reduce risk. For students targeting fintech, digital banking, lending startups, or credit scoring companies, this project becomes a strong resume highlight. It signals that you can work with structured financial datasets and build models trusted in real-world lending workflows. As you dive deeper into this project, the second slide explains the core skills you must build to make your loan default prediction model accurate, reliable, and ready for real-world use. At the heart of this system is binary classification, which simply means predicting whether a borrower will repay or default, and this requires you to understand common algorithms like logistic regression, decision trees, random forests, XGBoost, and LightGBM. These algorithms help you capture patterns in repayment behavior, but to use them effectively, you also need strong feature engineering skills, because financial data hides important signals like debt-to-income ratio, credit utilization, payment history, and employment stability. These signals act like clues that tell you who is financially healthy versus who might struggle. Another challenge is that default cases are rare, so you learn to work with imbalanced datasets using methods like class weights or synthetic data generation to keep your model fair and useful. At the same time, lenders operate under strict financial regulations, so you gain exposure to compliance, explainability, and fairness requirements, which are crucial in banking and fintech. Recruiters value students who understand both the technical and regulatory sides because it shows maturity and responsibility in handling sensitive financial data. By mastering this skill set, you position yourself strongly for high-demand roles in credit analytics, risk modeling, and financial machine learning across banks, NBFCs, credit bureaus, and lending startups. This slide walks you through the full implementation roadmap, and it shows how you can turn this project from an idea into a complete end-to-end ML system that mirrors what real fintech companies build. Okay. You start by gathering datasets that capture essential financial details like credit score, income, employment length, loan amount, and debt levels, because these are the signals lenders trust when making decisions. You then explore this data to understand how default patterns vary across different groups, which helps you see trends that models alone might miss. Next, you engineer features that make these signals more meaningful, such as ratios that show financial stress or scores that capture repayment stability. With these features ready, you begin training multiple models like logistic regression and boosted trees, comparing their performance using business-focused metrics rather than accuracy alone. You also interpret your models using tools like SHAP values, so lenders can understand why a prediction was made, which is essential for trust and regulatory compliance. Finally, you integrate the model into a workflow that sets decision thresholds, estimates expected profit or loss, and supports automated or assisted loan approvals. This roadmap gives you a clear technical timeline, from beginner stages where you master basics in about 6 to 8 weeks, to more advanced stages where you refine ensemble methods, fairness checks, and deployment. By following this flow, you learn how real credit scoring pipelines are built and monitored in production. This slide focuses on the powerful career and placement opportunities unlocked by completing a loan default prediction project, and it shows why this domain is one of the strongest hiring markets for AI and ML students in 2025 and beyond. This slide is inspired by the foundation of commerce and modern projects. When you understand credit scoring, risk modeling, imbalanced learning, and model interpretation, you instantly qualify for roles like Credit Risk Analyst, where you help lenders make smarter approval decisions using predictive models. You can also aim for roles like Risk Data Scientist, where you build risk models across multiple financial products, or Fintech ML Engineer, where you deploy scalable models inside digital lending platforms used by millions of customers. Recruiters specifically look for candidates who can engineer strong financial features, explain model decisions using tools like SHAP, and apply fair lending principles, because these skills ensure compliance and reliability. Companies such as HDFC Bank, ICICI Bank, Axis Bank, Paytm, Cred, and major NBFCs actively hire for these capabilities. And salaries can start around 8 to 15 lakhs for freshers in India and rise to 18 to 30 lakhs with a couple of years of experience. US entry-level roles often range from $85,000 to $135,000, making this a global opportunity. With most fintech companies already using ML for credit decisions, the demand keeps growing, and projects like this prove you can solve real business problems. Start building this today and put it on GitHub.